Hello, welcome back. We are going to continue this trig unit. So far we've been using trig functions and we've been given all the sides, or we've had to find a side and then write all the trig functions down. Now we're going to change it up just a little bit. We're going to find a missing side based on the angle and a different side given. So it's just kind of a change up. And then we're going to kind of switch gears, and instead of looking for side lengths, we're going to use inverse trig functions to find missing angles, right? So let's get going. All right, still working with missing sides here, okay? But we're going to plug in, same formula, but we're going to plug in a little bit differently, okay? So if they give you a diagram, here's our diagram over here. Whoa, what happened there? I thought I had my pen set. I didn't. Okay, so here's our triangle that we're given. Okay, all right. Go ahead and label your sides because it's always good. Draw your triangle, label your sides. Okay, here is the angle in reference. All right, it's 24 degrees. This is the side opposite. This is the hypotenuse. Why? Because the hypotenuse is always across from the 90-degree angle. Okay, so label the sides that you're given. Now, I'm given information about, I have an angle, the side opposite, and I'm looking for the hypotenuse. So which trig ratio uses, trig function uses a ratio of opposite over hypotenuse? Well, that's sine. All right. Now, instead of writing an angle A, B, theta, beta, we're actually going to plug in a degree value. All right. So sine of 24 degrees equals the side opposite, 11, over the hypotenuse, which is x. All right. Now we're going to solve for x. So when x is in the denominator, the thing behind the thing is that you multiply both sides by x. So I get x times 20, sine of 24 equals 11. So that means x has to equal 11 divided by the sine of 24. Remember that the sine of 24 is just a number. Remember when we were working with literal equations and we said anything that's not the variable, we just treat it as a number? Well, this is a number. This is a number, and you're just going to divide by it. So on your calculator, you're going to take 11. Everybody pull out your calculator. It's a good idea to have your calculator for these lessons here. And you can take 11 divided by, then press the sine key, and then 24 degrees. You do want to make sure that your calculator is in degree mode. And then hit enter. And you get 27.04, and we're going to round to the 10th. That's one decimal place. So that is 27.0, or just 27. Okay, that's the side length. That's the length of the hypotenuse. Okay. Let's try this next one. Okay, again we have a 24-degree angle. I haven't moved the angle on you, but this time we're given information about the side opposite and then the side adjacent. So which trig function uses a ratio of opposite and adjacent? Well, that would be tangent. So the tangent of 24 degrees is equal to the side opposite, which is 11, over the adjacent, which is x. So again, we're going to solve for x. We're going to multiply both sides by x, and I get x times tangent 24 is equal to 11. And then I'm going to divide both sides by the tangent of 24. and I get x is equal to 11 over tangent 24. So when I use my calculator, making sure that I'm in degrees, okay, all right, I'm going to do 11 divided by tangent 24. And I get 24.7. So x is equal to 24.7. 24.7, whatever that unit is. I got on my calculator, I got 24.70. Okay, so that 0 following the 7 says just let it ride. It's just keep it at a 7. All right, why don't you try this one? Hit the pause button, come back and see if you can get it right. All right, welcome back. Here's my angle, 64. This 4 is the adjacent. This x is my hypotenuse. Sorry, I should have done that. Hopefully you caught that. All right? Okay. So, which ratio uses adjacent over hypotenuse? Well, that is my cosine. So I'm going to use the cosine function. All right? Now I have the cosine of an angle, 64 degrees, has to equal the side adjacent, which is 4, over, let's write this over here, A over H, over X. So again, I'm going to multiply both sides by X, and I get X times cosine 64 is equal to 4, and I'm going to divide both sides by the cosine of 64. And then I get x is equal to 4 divided by cosine 64, 4 divided by cosine 64. 9.12, so that keeps it at 9.1. Just like that. And you're done. All right. Now we're going to change gears a little bit and we're going to find a missing angle. And this is where the inverse trig functions come in. You'll see them as sine -1, cosine to the -1, tangent to the -1. All right. Those aren't like, exponents. It's a way to designate that you're taking the inverse of it. Okay, you've seen that in function notation. When we talked about function notation, we had f of -1. That was an f to the -1. That was the inverse function. All right. Okay. Here's a little nugget of truth. Okay, so we have these inverse operations. Addition undoes subtraction. Division undoes multiplication. So there are these inverse trig functions that undo the trig functions. All right. So we use them to find angles. When we're looking for an angle, you want to think of inverse trig function. When you're looking for an angle, you want to think of inverse trig function. The trig function you use depends on the sides that they give you. You're going to use the inverse sign if they give you the side opposite and they give you the hypotenuse. Then you're going to use the inverse sign. Okay? So let's try one of those. Again, label your sides. Here's the angle in question. So this is the side opposite. This is the hypotenuse, and here is the adjacent. All right. Which sides are given? Well, we're given opposite and hypotenuse, right? So that means, based on SOHCAHTOA, we want to use the sign, right, for the SO. So we're going to use inverse sine is the trig function we're going to use. And this is the way we write it. Inverse sine of the side opposite over the hypotenuse is going to equal the angle. Let me go back a slide because I just kind of blew right through this. Inverse sine of the side opposite over the hypotenuse, that's going to give you the measure of the angle that you're looking for. A lot of times this will be like x degrees, okay? X degrees. The thing that you're going to plug in here is you're going to plug in the side opposite, and you're going to divide by the side, the hypotenuse, okay? So here we are back on slide 6. I have inverse sine. I'm using inverse sine because they give me information about the opposite and the hypotenuse, all right? And then that's going to give me x degrees, or the measure of my angle, right? X degrees. All right. So for this problem, we have inverse sine of 6/10 is equal to x degrees. All right, so here's how we're going to do it. So everybody grab your calculator. You're going to press the second button. On the TI-30X2S, it is on the upper left-hand corner. That's going to activate your inverse functions. Second, and then you're going to press the sine button. That'll activate that little thing above it, inverse sine. And you should have sine -1 parenthesis. Then you're going to plug in your opposite, hit the division key, hit 10, close it off with a parenthesis, and hit enter. Now, what you have is 36.86 or 87. And we're going to round to the nearest, to 1 decimal. So that means this is above 5, so I have to round this one up. So it's 36.9 degrees equals x. Okay? To find missing angles, remember you use an inverse trig function. Inverse trig function. You're going to use the inverse cosine if you're given information about the adjacent and the hypotenuse, because those are the things that cosine work with, right? So here we are. We have inverse cosine of the adjacent side over the hypotenuse has to equal the measure of an angle. And what that's going to be is, this is what you're looking for. This is going to be like x degrees. Okay, same type of thing, only different sides. Again, label your side. Here's the hypotenuse. Here's the adjacent side. Here is our angle in reference. All right, so here we go. Which sides are given? Adjacent and hypotenuse. So I'm going to use the inverse cosine. So I'm going to write it out as inverse cosine is the side adjacent over the hypotenuse. I'm going to write it out so that I remember what I'm doing, because I'm mathematically minded, and this helps me to figure out what comes next. All right, so now I'm going to plug in my own stuff. Cosine, inverse. My adjacent side is 6. My hypotenuse is 14. And that's going to give me x degrees. So now I'm going to follow these same instructions, and I'm going to press my second key. Then I'm going to press my cosine. It's going to activate cosine -1 parenthesis, and then I'm going to put in 6 for my adjacent side, divided by 14 for my hypotenuse, close it off with a parenthesis, and press enter. That gives me 64.62 degrees. All right. 2 is less than 5, so this is just going to be 64.6 degrees is equal to x. That's the degree of that angle. See how these trig functions are so handy, handy, handy? It's amazing. I just find it so fun. All right. Again, we have one more, and it's called the inverse tangent. And we're going to use this when we're given information about the side opposite and the side adjacent. All right? So, inverse tangent is going to be inverse tangent of opposite over adjacent is going to give us the measure of our angle, which often will be called x. When you're looking for x degrees, you're looking for an angle. So let's use that. So first I'm going to label my sides. Here's my angle in question. This is my adjacent side. This is my opposite side. So I am given information that I can use tangent. Remember, tangent is opposite over adjacent. So the inverse tangent of my opposite over adjacent is going to give me the degree measure of my angle. I'm going to plug in my information from this diagram. Just like so. And then I'm going to go back to my calculator. And I'm going to use it. And I'm going to press the second key, then the tangent button. That activates inverse tangent, tan -1 parenthesis, and I'm going to plug in my values, 24 divided by 8. Close it off with a parenthesis and hit enter. And I get 71.56. I'm asked to round to one decimal place. This is above 5, so I'm going to round that up to 6. 71.6 is equal to my degree measure. Okay. All right. I'll have a lesson sheet for you tomorrow. I hope you enjoyed watching this. It was not too long, so if you need to re-watch something, please do that. I'll see you tomorrow, and thanks again for watching.